Hey, Morty, let me ask you a question real quick. Does evil exist? And if so, can one detect and measure it? Rhetorical question, Morty. The answer's yes, you just have to be a genius.
Alright, Morty. For this distillation column, Morty, what we need to do, we need to find the open steam requirement. That's part one. So what we're gonna do is we're gonna take what we know. We know what's in the feed, and we're gonna use the data that we're given in the problem to find the alcohol in the distillate. So once you find the alcohol in the distillate, then you can use that. You can use that to find the water in the distillate by using the percent of the distillate that's alcohol. And then you can use your reflux ratio, L over D, which is equal to 3. You can use that to find out. And then once you find that, you can find V. You can find V. V is L plus D, Morty. Morty, V is L plus D. Morty, once you find V, then you know that the vapor, that the open steam, that the vapor in the open steam in the bottoms, you know, this is the same as the vapor up top, which is 50.8 kmols per hour. So you got the first part already solved, Morty. You got the first part already solved, Morty. And then Morty, what you're gonna do is you're gonna take the alcohol that's not up top, and that's the alcohol that's in the bottoms. And then to find L prime over here, you can use that. This is L in the rectifying section, liquid in the rectifying section in the bottom. That's liquid up top plus feed, Morty. Morty, that's liquid up top plus feed. And that's 138.1, Morty. Let's take a look at how to do part B. It's pretty simple, Morty. This is just a 45-degree line. It's just a 45-degree line, Morty. It's pretty simple, Morty. Alright, next. You plot your equilibrium data, and you get your equilibrium line, Morty. It's pretty simple, Morty. Up next, we get the Q line. The Q line is just starts at your feed, and then since it's a saturated feed, saturated liquid, it's vertical, Morty. It's vertical. You can see it's vertical. And after you get your Q line, so things start getting crazy. Alright, Morty. Here we get the rectifying section operating line slope. It's really simple to find. You just do L over V, and you know L because you solved it over here, and you know V because you solved it over there too. So you just plug that in, and it gives you 0.75. You do a real similar thing, L prime over V prime for your bottoms, for your stripping section. So you just plug those in, and it gives you the slopes of the line that you'll use in your graph. After that, Morty, you use the slope that you found. You use the slope of your rectifying section for this part here. It's your slope of the rectifying section right there. Just start at the distillate and go down to the Q line. Q line is real simple, Morty, just real easy. And then you use the slope of your stripping section, and you start at the bottoms. You work your way up. To the Q line, Morty. Just work your way right up to the Q line, and here's where it gets fun. You just plot your stages. So you start at the top, and you go over from your distillate, and you go horizontal to your equilibrium line. And you go straight down vertical to your rectifying section line, Morty. You go over and down. You keep doing that all the way down. So that's the distillate. This is the distillate at the right, and then Morty, you go down over here, and there's your Q line. You keep going. You go right past it, and you go down, and then you find where the stage crosses the bottoms, and then you're done. And then that's it. And this stage here, that's the 19th stage, Morty. That's the 19th stage, and that's where the feed comes in. That's the optimal feed location. 19th stage, and this is the 21st stage. So you need 21 stages. 21 stages here. That's it. Well, you gotta do the last thing is find your minimum reflux ratio. And so, Morty, you find your L over V min by using your graph where the operating line touches the equilibrium line, and you get a million, you get infinite stages, and that's your minimum reflux ratio. And so you find your slope there, and it's 0.667, and then you find your minimum reflux ratio, L over D min. It's equal to L over V min over 1 minus L over V min, which is equal to 2, Morty. Your minimum reflux ratio is 2.